Hi everyone, my name is Hakan and today I'll be showing you how to get started with LINQ, which stands for Language Integrated Query. LINQ is a feature in C# that makes working with data a lot simpler. And normally when you query data, you might want to write it as plain text like SQL for relational databases. But this can lead to errors that you don't catch until the program runs and you don't get much help from tools like IntelliSense. With LINQ, queries are built right into the language, just like writing methods or classes. This means that you get better error checking, suggestions as you type, and a consistent way to work with all kinds of data sources, whether it be in-memory lists or external databases. The key to LINQ is the query expression. It's a simple and clear way to filter, sort, group, or transform your data. And the best part of it is, once you learn how to use it, you can apply it on any type of data source. So LINQ can be written in two ways. First, which is the query syntax, which is a SQL looking like syntax. And the second way is the method syntax, which are extension methods on the IEnumerable interface. And today we'll be focusing on the method syntax. So let's open our IDE and start writing some LINQ. So I've got a console application set up with a list of employees, and an employee is a simple object that contains a name, department, and a salary. And we'll be using this list to write our LINQ queries. So let's start with something easy, like getting a list of all the employee names. Without LINQ, we'll do that by the following way. We'll create a new list. Let's call it for names is new list of type string. And then we'll go ahead and iterate over the employees list. So we'll say for employee in employees. And then we'll add each name to the names list. So we'll say names.add employee.name. And then we can go ahead and dump the names to the console. So let's say dump and run the code. And then we can see that we got a list of all the employee names. And by the way, this output is made possible by the dump method from the dumpify package. I just found this recently. I think it's really great to see objects like that outputted inside the console. And I thought it would be great for this video to see what the output of the LINQ methods is. So now let's actually convert this to a LINQ method, or let's use a LINQ method to get the same result. And all we have to do is say employees, and because employees is a list which implements the IEnumerable interface, that gives us automatically access to all the LINQ extension methods. On the employees, we can go ahead and call the select method for this case, and provide it a lambda to select the properties we want. And in this case, it's the name property. If we go ahead and hover over the select method, we can see that it projects each element of a sequence into a new form. So it means it transforms the element which it iterates over to something else. And in this case, a string, the name property. And we'll take that string, put it inside of a new collection. And then when the select method ends, it returns that newly created collection. It returns an IEnumerable. So if we hover over the names variable, we can see that it's a IEnumerable of type string. And if we go ahead and run this code, we can see that we get all the employee names again. And right away, we can see that with LINQ, we have to write a lot less code. And that's just really where these LINQ extension methods excel at. They really make the code more readable, more maintainable. And these methods work really fast. They're really efficient. They work great. And they just make developing and working with data source really easy. So next, let's apply filters with LINQ, because let's face it, using a filter is one of the most important parts when working with data sources. And to use a filter, we can use the where method. So let's say for result is employees.where. And this where method takes in a predicate, which it uses to check which elements it needs to return inside of a new collection. So we can do say x.department should be equal to, let's say, department.hr. And that will give us all the employees which work for the HR department. So let's say dump here and run the code. And now we can see that we get back a collection with only employees who work for the HR department. And you can filter based on any other property you want. So let's say you want to filter on the name property, you can do that. So let's say employee.name should or starts with the letter P. So if we run this, we get one employee because there's only the name Patricia starts with the letter P. And the beauty of LINQ is that you can start chaining these methods because right now, because all these methods return a new IEnumerable and these LINQ methods are available on the IEnumerable interface, we can go ahead and do a select after a where. and perhaps select the salary that Patricia earns in this case. So let's say salary. If we go ahead and return that, we can see that Patricia earns 67,000, which is true. There's the 67,000. So that's really a nice feature, being able to chain all these link methods to create a collection that you want. And a little bit of advice is always first use the where method, then after use the select method, because you don't want to project all your elements or all the elements inside of a collection and then return a couple of elements of those with a filter. You always first want to filter out the elements you need and then project it to the type or object you want. Otherwise, you'll be wasting resources. Next is grouping related data. So let's go ahead and comment this out. Take this up perhaps. And let's go ahead and group all the employees by the departments. So to do that, we can say for result is employees, and then we use the GroupBy method, which takes in a key selector. So groups the elements of a sequence according to a specified key selector function. In this case, that will be the department. So this will create a enumerable of grouped elements, and they will be grouped by their department. So if we go ahead and run this code, we can see that we get a list. Let's make it a bit smaller. We can see that we get a list with grouped objects. So the HR employees are grouped, the IT employees are grouped, finance, marketing, sales, etc. And what we can also do is, perhaps to make it more easy to read, we can convert this to a dictionary by saying .to dictionary, and then we have the group, and on the group we'll use the key as the key for the dictionary. So we'll say group.key, and then that's actually it. We don't need anything else. And now we can see based on the key, which makes it easier to read, that the HR department contains these employees, the IT department contains these employees, etc., etc. And another nice thing perhaps you can do is, let me see, copy this and add here. So I could say the group and then count the group. So this will count how many employees are in that specified group. And let's go ahead and run this code. And then we can see that the HR department contains 2 employees, IT 3, finance 2, marketing 2, sales 1. And the count method's also a link method on the enumerable. And again, on these, because this also returns an enumerable or a dictionary which implements the enumerable interface, we can chain other link methods like the where again. And we can say the value should be less than, let's say 3. So if we run that, we can see all the departments that. Now let's look at 2 important link methods which return booleans, which are the any and the all method. So we have the any method, which is used to check whether an item exists in the collection. So we can use the employees.any, and if we don't provide any argument to it, it will just check whether the collection contains any items. So it determines whether a sequence contains any items. If we run this, we get true because the collection contains items. If we comment all of this out and run it again, we should get false because the collection should be empty. And what we also can do is provide a predicate to this method to check whether there is at least one item that satisfies this condition. So let's check if there is an item where the salary is at least 50,000. If we run that, we get true because there are a couple of employees who earn more than 50,000. If we check whether someone earns less than, let's say, 20,000, then it returns false because there are none of them. And this any method will just iterate over the loop and check the condition. And once this condition becomes true, so if there is a item inside the collection that satisfies this boolean, then it will go ahead and return the value immediately. So again, the any method has 2 variants, one which just contains whether the collection is empty or not, and the second checks whether at least one item is inside the collection that satisfies the given boolean or the given predicate. And next we have the all method, which checks whether all elements in a collection satisfy a specific condition. So we can say employees.all, and we can check whether, let's say, do they all work for the department of HR, and that should be false because there we have different departments. And if we check whether all of them earn at least, let's say at least 30k, then we should get true because all of them earn more than 30k. So that's the all method. It just goes through the entire collection and checks whether all of them satisfy this condition right here. And if one of them doesn't, then it short circuits and it returns false. So we can also use LINQ to return some analytical data like numbers. So let's go ahead and comment this out again. And let's start with like averages. We can return averages. We can say if our result is employees dot average, and then we can check what the average salary is. So if we go ahead and run that, we can see that the average salary is 64,900. We can check what the min and max value is. So let's go ahead and copy this, and then use the min, and we also have the max. If we run this, we get that 44 or 45,000 is the minimum value or the lowest value in the collection. And if we go and run this code, we can see that 82,000 is the highest value in the collection. And so it will count only by the given property, so it won't count the salary property. You can use it on any other property, but in this case the salary property makes most sense. And you can also sum everything up. So for result is employees dot sum x dot salary to see what the total salary is. That is 649,000. So those are a couple of LINQ methods that just return numbers. And now let's go ahead and see how we can combine a couple of these LINQ methods. So for example, let's check what the average salary is in each department. So what we can do is say if our result is employees, and then we can say something like .GroupBy, and then we'll again group by the department, and then we'll project it to a new object, a anonymous object, and we'll say new anonymous object, and let's say department is the key, and say average salary is the average of the group. That will be e dot salary, and that should be it. Let's go ahead and run this code. And now we can see what the average salary is per department. So we can see the averages, the average of HR, IT, finance, marketing, sales. So yeah, that's really nice. This way we can combine, we're combining the GroupBy with the select, and inside of the select we're using the average. So you can use LINQ methods inside of LINQ methods. So this shows us that LINQ is really flexible and you can get really creative with these LINQ queries. Next, let's do some ordering and getting a single item instead of a collection. So what we can do is let's go ahead and comment this out and move this up. And let's say we want the highest paid employee. So for that we can order the list and check, we can order the list by the salary and check whether what the highest paid salary is by taking the last element of that list. So we can say if our result is employees dot order by, and then we can say x dot salary, and then take the last element of the collection. So this will return an employee and not an enumerable of employees. So if we go ahead and run this, we should get the highest paid element or the highest paid employee, which is Robert with the 82,000. And we can also reverse this by using, let me just copy this. And we can reverse this by saying order by descending, and then we'll get the first element. Because now the highest paid employee starts on the first position, so on index 0. And then we'll get the first element because that's the highest. If we get the last element, then we'll get the lowest paid employee. So this should return the same result, employee Robert. So this first and last method are used to return a single element of the collection instead of something like, let's say, the where or the select, which returns a new enumerable or a new collection. And these methods also have a default version of them. So instead of first, we can say first or default. And what this will do is, because let me show you what happens with first, what can go wrong, is when you want to use the first method, but there are no items in the collection, then the first method will throw an exception because it can't find any. Sequence contains no elements, so it will return a... so this is what happens with the first, it contains no elements, so then it will throw an exception. But if you use first or default instead of the first method, then all of a sudden you won't have a exception, but you will have a null return because the default value of a employee, which is a reference type, is null. So this is pretty handy if you want to avoid exceptions during runtime. Then I advise you to use the or default version of these methods. So you have the first or default, you got the last or default, you got single or default. So these will all return null if they can't find any item. And another thing is with all of these methods, with the first, last, single, all of them, what you can do is provide a predicate inside the parentheses, which will actually work like a where method. So if I go ahead and comment this out and say for result is employees dot where, I mean first. So let's say what we had Patricia contains or the only one starts with the letter P. So if we say again name dot starts with the letter P, then we get Patricia back, but as an employee this time instead of inside of a collection, we get the employee object because the first returns an employee, so result becomes an employee instead of like what the where does, which returns an enumerable. 1, 2, 3. So the same can be done in the last method and the single method, and this can also be done in the inside of the count method, which is available. So if you want to count employees, count, I mean the count method, not the count property. So that's a really big difference because lists contain a count property because it inherits from iCollection, but enumerables have the count method, which is a bit different. And this count method, you can either leave it as it is and provide no argument, and it will go ahead and count the entire collection, or you can provide it a predicate and say counts employees that earn a salary higher or equal to 75k, run the code, and then we see that we have 3 employees that have a salary higher than 3 or 75k. And next is the take and skip methods, which can be used like for pagination, but in this case I'll be using it a bit differently. So let's go ahead and put this one up. And so take, we can use take to take a couple of elements that we want. So let's say we want to search or get a list of the top 3 earning employees. So we'll say for our result is employees dot order by descending, and then we'll take the salary, and from that we want to take 3 elements. So this will return a new enumerable with 3 elements if it can find 3 elements, and that's these employees, which are the top 3 earners. And another thing is if we only have, for example, we have 2 employees, then it will go ahead and return 2 employees and won't throw any exception or something like that. It will only return 3 if it can return 3, else it will return less, and it will return empty collection if it can't find any. So there's also a skip method, which works kind of the same, but then it just skips those elements. So let's say we'll skip 9 elements and take 1. If we skip 9, then we get the last element of the list because we're ordering by salary. So the lowest earner is at the last position. We're skipping 9 employees, and then the 10th we're taking. And that is in this case the lowest paid employee. But you can use this mechanism also to use pagination. For example, when you're querying a database, that you can skip a couple of pages and then take your page count. Also, I want to show you a couple of LINQ methods that were actually recently added in .NET 8 and .NET 9, which are the minby, maxby, countby. So let's go and see how they work. If we go ahead and get the result. Let's say something we did right here for getting the highest paid employee. There was this one where we order by descending the salary and then get the first item to get the highest paid employee. But I think since .NET 8 we can actually do that much simpler by saying result is employees.maxBy, and then we can give it the salary as selector. If we go ahead and run that, we get Robert with the highest paid, who has the highest salary, and we can do the same with the min.by to get the lowest paid employee, which is Chris with 45,000. And we also have the count.by, so something we did earlier with the grouping and checking how many employees were inside that group. We can actually also do the same with the count.by, so we can do count.by and then we'll say x dot department, and then we can see how many employees each department contains. So HR got 2, IT got 3, etc., etc. I think this method was introduced in .NET 9, and these maxby and min.by were introduced in .NET 8. So also a new LINQ method added in .NET 9 is the index method. So that is the for result is employees.index. And what this returns is an enumerable with a tuple or the index and an employee. And this can be used in a for each loop actually. So instead of so let's say you need the index inside of a loop, instead of doing something like for int as I, etc. You can actually do for each var item, or let's say index employee in employees.index. And now you've got access to the index of each employee and the employee itself. So that's a pretty nice feature. Instead of using the standard for getting indexes, you can now use the index method on the enumerable to get a tuple with an index and an employee in this case. To see what it looks like, let's go ahead and say for result is employees.index. Let's run the code. And then we can see that John has an index of 0, etc., etc. So that's a pretty nice feature. So the last method I want to talk about is the distinct method. So let's go ahead and comment this one out, move this one up. And so let's say all these people have the same name. So let's call them all John, 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 and perhaps the rest we'll call all James. And right now if we go and select all the names again, so if our result is employees.select x.name, and if we run that, we get a lot of John and James. Now let's say we only want distinct items, so we can call distinct on that, the distinct, which returns distinct elements from a sequence by using the default equality comparer. And because they're all strings, they'll just be compared to each other. And if we go ahead and run this, we get only 2 items, John and James, so distinct items. And we can also get the same output by writing it a bit differently with the distinct by. So then we'll say distinct by, and then we'll have to provide it a property. So in this case, the name, and then after that we can say select the name property, and that should give us the same result, where we get John and James. And that's actually all the LINQ methods I want to talk about in this video. Unfortunately, I can't cover all of them in a single video. This is actually all the methods available in the enumerable class, which are all inside the system.link namespace. And there are a lot of them. This list just keeps going on. So I would advise you to check these methods out, try them yourself, and just play with them, get familiar with them, especially get familiar with lambdas and delegates if you don't know those. But LINQ really is great. It makes life a lot easier. You can work with any kind of data source. And yeah, it's just good. It's really good. So thank you for watching, and I'll see you next time.